The Atomic Structure of Metals by Eve Brana Anabudi.
All the atoms of metals tend to lose one or more than one electron from its outer shell when they form a compound with a non-metallic atom. Thus, they become ions. For example, the sodium atom has one electron in its outer shell and it tends to lose its one electron and thus becomes sodium by the power of 1 plus ion.
The blue dot is the electron in the outermost shell in a sodium atom, and the gray one with the plus sign in the middle is the nucleus of an atom containing positively charged protons and neutrally charged neutrons.
In this, you can see several sodium atoms and their outer electron orbiting the nucleus. The outer electrons form the sea of electrons, which are attracted to the nucleus just like they are glued. The attraction between the electrons and the nucleus is called the metallic bond. This ball with the plus sign is not only the positively charged protons, but all the protons and neutrons of the sodium atom. The atom is positively charged because the outer electron gets delocalized and the electron is just floating somewhere. Thus, the atom has one extra proton. To form the strongest metallic bonds, metals are packed together as closely as possible. Thus, they are crystalline solid at room temperature and have high melting point. How metals conduct electricity. For example, I took sodium, and this is the sodium atoms, and the delocalized electron. When a current passes through the wire, the delocalized electrons just move through the wires, like from to the red wire and come back by the blue wire, and by this way they conduct electricity.
Here are some main properties of metals. First, ductility. Second, malleability. Third, lustrous. Fourth, high tensile strength. And fifth, good conductor of heat and electricity. So here you can see the definition of the words I mentioned before. Ductility. It is the ability to flatten without shattering when hammered or pounded. Malleability. The capability of getting extended or thinned out without breaking. Lustrous. The ability to shine. High tensile strength. The maximum load that the metal can support without fracture when being stretched. Conductor of heat and electricity. Ability to conduct electricity and heat. Every carbon or atom in a diamond makes 4 strong covalent bonds. To melt diamond, you have to break all these strong covalent bonds, and this requires a large amount of energy. The diamond structure is a crystalline structure built up with lots of small tetrahedral units consisting of 5 carbon atoms, which are joined together to form the giant covalent structure. Properties of diamonds. The melting point is 3,550 degrees Celsius, and the boiling point is 4,830 degrees Celsius. Hardness. High electrical resistivity is resistant to chemical corrosion, low thermal expansion coefficient.
The atoms in the graphite structure makes three covalent bonds, and very high energy is required to break these bonds, like the diamond bonds. There is a one delocalized electron per carbon atom in the graphite structure, and these delocalized electrons can move from one atom to another atom, and this means graphite is a conductor of electricity. As you know, we mentioned it before, and main properties of graphite are soft and slippery, crystalline solid, good conductor of electricity, non-inflammable, good conductor of heat. The structure of the silicon is similar to the covalent structure of diamond. The only difference is that diamond contains carbon atoms and silicon dioxide contains silicon atoms. Each silicon atom makes four strong covalent bonds. In order to melt silicon, the strong covalent bonds have to be broken. Silicon is not a metal, but a metalloid. Main properties of silicon. Melting point 1410 degrees Celsius. Melting boiling point 3265 degrees Celsius. Very brittle semiconductor, solid at room temperature.